This is space, and this is an egg moments before I attempted the world's highest egg drop. Now in an egg drop competition, in case you never had the chance to do it yourself in school, the goal is to build a contraption that can protect a raw egg from breaking when dropped from the tallest height possible. So my original plan was to drop an egg in a contraption I built from the world's tallest building. But humans are always building taller buildings, so if I really wanted to future-proof this record, I realized I would need to go all the way to the top and straight to outer space. And when I started on this journey 3 years ago, I knew if I could draw on my experience of landing stuff on other planets, I would be guaranteed the record. But what I didn't know is this would be the most physically, financially, and mentally draining video I would ever attempt. But first, let me just explain what I was thinking. The plan was to clamp an egg to the front of a rocket, then attach that rocket to a weather balloon and take it up to space. Once there, the weather balloon would release it, and just by using gravity only, the rocket would eventually accelerate past Mach 1, breaking the speed of sound, and then it would autonomously adjust the forefins on the back to steer itself to the target location, and then at 300 feet above the ground, it would release the egg, which would free fall onto a mattress that we'd placed on the ground. And that all seemed pretty straightforward. So like any good engineers would, we broke the problem down into smaller steps, starting first with calculating the terminal velocity of an egg. And by terminal velocity, I mean that any object, including humans, have a maximum speed at which they fall once the force of Earth pulling you towards it balances with the pushback force from bumping into more and more air molecules as you start to fall faster. For humans, that max speed is about 120 miles per hour, and after doing some simple math for an egg, it tops out at 75 miles per hour. So to make sure the egg wouldn't break if we dropped it onto a mattress at its terminal velocity, we ran our first test. And since we couldn't find a tall enough building whose lawyers would agree to let us hurl an egg off the side and onto a mattress, we had to improvise a bit.
83.
Yes! Check the egg. No cracks. So our mattress will protect an egg even if it's traveling faster than its terminal velocity. That's a good start. The next step in our DIY space program was to head back to my friends in the small farming town of Gridley, California, which is the place where we broke the elephant toothpaste world record, where the plan was to set out a target mattress for the egg to land on in the middle of a field, with a little bit of margin built in just in case.
All right, so we've got the smoke charge back here so that as we're like coming down from the sky, we want to be able to pick it out. This is the computer, here's the fins.
This, by the way, is Joe, and he has a fascinating channel called BPS Space. And what makes him especially cool is he didn't go to school for any kind of engineering degree. He's all self-taught and recently even landed a launched rocket SpaceX style after 7 years of trying. Joe was in charge of tracking and guiding the rocket to the mattress using these movable tail fins, whereas I was in charge of the payload. In other words, how we would keep the egg from freezing on the way up in a little oven with heaters which would break away before we dropped, along with the mechanisms to release the egg itself. Release the egg! And the purpose of this first trip to Gridley was a flight characterization test. Basically, before we spent all the time and money taking the balloon all the way up to space, we were here just to do a low altitude test at 10,000 feet, just to prove to ourselves we could steer the rocket using the fins. We're setting all sorts of world records out here. World's largest mattress, fastest egg,
Yep.
tallest egg drop. What could possibly go wrong? Besides like 4,000 things. And so with everything more or less in place and ready to go, all we needed now was an official egg, which thankfully Gridley has in abundance. Hi. I'm sorry. This is terrifying.
Okay. Oh, no.
Hey.
Precious egg.
In the history of our universe, this is the first chicken that's ever laid an egg that will go faster than the speed of sound. Supersonic. Mach 1.
Thank you. I'm sorry, I'm leaving. Congratulations.
So the next morning we got up at 4 a.m. when the winds would be the most calm to run through all our final pre-launch preparations. Loading up our lovely egg. Including the last minute decision to add a metallic streamer to the back of the rocket to make it easier to visually track.
We've got redundancy all over the place here. We've got redundant leads, redundant igniters. Mark has 2 servos on the fairing. No dumb failures.
And that's exactly when we had our first dumb failure.
All right. The GPS is mad.
We gotta scrub the launch. We were just walking back, and the egg's all bloop, and it pooped it out. And scrubbing the launch meant we unfortunately had to release all the helium out of the balloon, which is an opportunity I'm not gonna let just pass on by.
Hello, wow, that's so cool.
And back at home base, we ran some tests that confirmed our hypothesis that since the GPS unit was right at the back of the rocket, the last-minute addition of the metallic streamer was interfering with the GPS signal, and that messed up the rocket's math in calculating its speed, so it thought it was time to release the egg. So early the next morning, we were back at it with a few modifications, the most important being swapping the metallic tracking streamer with one made from plastic. The good news is there's hardly any wind today. Bad news is about 20 degrees colder, which means our mattresses are kind of frozen. Nevertheless, we pushed forward. Don't trip, Mark. As I very carefully delivered the rocket to the new balloon launch site.
Send it.
Send it, baby, full send it.
It's happening.
Should we see it?
Oh yeah, I see it.
Oh, there it is.
And while the whole thing looked really cool,
So we might be in trouble.
we quickly realized the balloon was rising at a slower rate than we anticipated,
We're already south and we're only halfway up.
which totally threw off the predicted trajectory. And so after a few more minutes, we decided to manually drop the rocket because we were already way too far off course for the rocket to make up the lateral distance to the mattress using just the fins and gravity. 3, 2, 1, clicked.
Oh boy, that's not good.
And that's when we encountered the second problem of the day, as the fins actively forced the rocket into an uncontrolled death spiral. Altitude is 1400, coming down fast.
Well, it landed somewhere.
Check the mattress just in case. And since we had the GPS coordinates of the rocket, we headed out to track it down. The real question is, what's the status of the egg?
Mark, I think I might have some bad news for you.
At which point we stumbled on an entire field of sitting birds, which is another opportunity I'm not gonna let just pass on by.
That's a shoot, man.
Is that a suit?
There's no egg.
The egg did release. The fact that this is out means the egg did come out, so that's good. But despite that silver lining, the movable fins seem to be actually forcing the rocket into that tailspin, which was surprising because Joe had definitely run through a lot of analysis and testing before coming here. So after conducting a thorough review of the footage and firmware, he was able to locate and fix a single rogue negative sign in the code that seemed to be causing all the control issues, which meant we were ready to give this one final try. We had run out of spare parts and spare weather balloons, so regardless of outcome, this would be the final attempt. If we couldn't land the egg on a mattress from 10,000 feet up, we wouldn't have any hope of pulling it off, coming all the way down from space. Phenomenal! That's nerdy space talk for everything is exactly as expected. I'm standing in the middle of the world's largest mattress, where hopefully the egg will be landing in like 45 minutes. Otherwise, we're pivoting. And my new video is world's largest mattress.
So I'm arming the rocket right now.
The last step. All right, old girl, you're in for a ride. 3, 2, 1, let it ride, baby.
Looking good so far. We're at 500 meters.
Now, in order for the balloon to hit the target mattress, for each launch, we'd started from different spots around Gridley, which raises an interesting question maybe you've wondered yourself. How do big balloons like hot air balloons steer themselves? Or I guess even just know where they're going to land? And the answer is, computers know the wind direction and speed at every height as you go up. So on a given day, if these are the predicted wind directions and speeds, we would need to launch here to be directly above the mattress when we got to 10,000 feet. But how we know all this information is the fascinating part, because every day it's someone's job to launch 2 balloons like this into the sky at noon and midnight London time. But this is done in over 1,000 locations all around the world at those same 2 exact moments. And these balloons all have something called a radiosonde attached to them that measures things like altitude, pressure, temperature, and wind, and then they transmit the information back to the ground stations, which gets fed into supercomputers, and that's the reason weather and wind predictions can be so accurate. So 2,000 of these massive weather balloons go up every day and then eventually pop and just land somewhere. And since they're transmitting a signal, some folks make a hobby out of just trying to track them down.
How close are we to the drop point?
Balloon release?
Balloon release. That's it.
And this time we were releasing right in the target drop zone, which was good news on one hand, but it raised some new challenges on the other.
Where is it?
Gravity!
400.
Gravity!
300.
You see something?
Altitude 98 meters. I think we're down.
Everyone okay? That was exhilarating.
So we were much closer this time, and we even managed to steer the rocket in the right direction just slightly.
We found it. Good.
Egg?
No egg.
No egg?
Wait a minute.
It's the egg!
The egg.
Oh, did it crack?
I mean, it's not cracked.
So after 3 failed attempts, we still seemed pretty far off from where we needed to be, which meant it was time for the ultimate phone a friend with my buddy Adam Steltzner, who you might recognize as this guy from when we landed Curiosity on Mars.
Touchdown confirmed. We're safe on Mars.
He has a PhD from Caltech, and he's also the chief engineer for Perseverance and Mars Sample Return. And so after explaining to Adam what we were trying to do, he immediately spotted a fatal flaw in our brilliant plan.
And you're doing terminal guidance to something about the size of a house. How are you going to do that? How do you do that? I mean, I know how you physically do that. How do you not get busted by the FAA?
In other words, we were basically attempting to make a precision-guided missile.
Dude, there are thousands of people who have done this before, and they are sworn by federal law not to say a single word to you.
And to be fair, he raised a good point. The people who could help us actually can't, and even if we figured it out ourselves, the ethics of just slapping that how-to video up on YouTube are questionable at best. And so after a fruitful discussion with Adam,
But we release at about the height, and then we do a lobbing. The thing you start to worry about is heating. You might want to start with a 2-stage thing.
we decided to pivot. And instead of a precision-guided egg landing on a mattress in a small town, we would set our sights on a much more general egg landing target by heading out to the desert. But as part of the pivot, we completely scrapped our old design and spent a couple months designing and building a new system that borrowed heavily from the Curiosity landing, because we figured if it could safely put a rover on Mars, it could safely land an egg on Earth. So we would still go to space on a weather balloon, but this time the rocket would have fins that didn't move, and it would be 3 times as long and 4 times as heavy to guarantee we would get the egg to supersonic speeds on the way down. Then just like NASA separates the cruise stage in the upper atmosphere and then uses aerobraking to dissipate a bunch of the energy and speed, we would separate from the back half of the rocket about halfway down after we'd already broken the sound barrier, and because the system now weighed much less, it would naturally aerobrake and reduce its speed to the new lowered terminal velocity. Then on Mars, the next step is the parachute deploy, followed by the heat shield separation, and we would follow in kind by launching our own parachute and then release our own nose cone, which would then expose our set of cushioning airbags, as you can see here, which we borrowed from the Spirit and Opportunity landings. It was intentionally ambitious and extremely complicated, but after a couple months of complete redesigning and building, we found ourselves in the desert feeling cautiously optimistic. And that was due in part to our lucky orange parachute, because when I left NASA, my friends gave me this rectangular piece of nylon. And for scale, that's the exact same rectangle here that's part of the parachute the Curiosity rover used to land. So that piece of parachute is actually one of the 80 rectangles you see here as they were running the final tests in the world's largest wind tunnel. And so it only felt fitting that after some scribing, a bit of cutting, and a little sewing, it had nobly repurposed itself for the new mission. So as the sun went down, back at the hotel, we worked late into the night on final preparations. This was an idea and a passion project 3 years in the making, and it took a staggering amount of work even to get us to this point. We had thought and prepared for so many things that could go wrong, and while I was feeling optimistic, I knew at the end of the day, it was the laws of physics that would ultimately determine our fate. So early the next morning, the crew in charge of the balloon got to the launch site to start filling it up. And this balloon looks a little different than the others because it's a zero pressure weather balloon. The advantage these have over a typical weather balloon is they can go higher up into space, carry more weight, and they're open on the bottom, which means they equalize to the pressure and it's impossible for them to pop. So when you want it to come down, you send a signal that will pull down on a string that's sewn into the side of the balloon, and it opens like a zipper and self-destructs. The downside is they're incredibly lightweight and so thin and delicate, you have to be really careful and touch it with gloves. And they were about an hour into filling it with the 4 massive tanks of helium we had on hand when we made a gut-wrenching discovery. Hey dude, I got bad news. We have to scrub. Start taking the helium out of the balloon.
Launch scrubbed. They had some issues that I guess they can't resolve by today. So we're sucking out the helium from the balloon and trying for another day. So.
So no.
Yep. Yeah. What are you talking about? Are you serious?
That's what it sounds like.
Now for context, Joe was in charge of this part of the rocket and me and my team were in charge of all of this. And while we'd each tested our individual systems ad nauseum, it wasn't until that morning that we were able to test the integration of the 2 systems together. And when we did, it became immediately clear to me I had made a critical oversight.
So, tension compression, this is great. It's holding on to that thing fantastically. The problem is, this is so long and heavy, as soon as it wiggles, it's going to want to bend. Great in tension compression, but this happening at Mach 2 is...
That's not gonna work out.
There's no other balloons in the world of this size that we can get access to. This was the only one for like another month. We're trying to save this one so we could hopefully reuse it, but any slight little damage, you touch it in the wrong spot, and now that's an imperfection that may actually be a failure point for a future mission.
And this was an absolute low point for me. The integration of 2 independent systems is such a classic failure point in engineering. I was crushed I had missed this. And financial concerns aside, I felt like I had just let everyone down. Not just my team and the rest of the crew helping out, but all the other folks, some of whom drove 6 hours to come out and watch as well. But that's the thing with failures. They can sting like crazy, but it's really just a process to learn one more way not to do a thing. And so even as I sat there feeling pretty bad, like any good engineer, I was already coming up with a list of all the things we were going to fix to get back out here and try this dang thing one more time. And this principle of resiliency is something I think can be learned. In fact, I believe this so much, I started a toy company called Crunch Labs with the express goal of helping kids think like an engineer. So with the Build Box, not only do you get a super fun toy that you put together every month, but you do it alongside me while I teach you all the juicy physics of how it works. We're right there in the trenches, building and succeeding together so the principles really sink in. So if you're a kid and you're looking for something to put at the top of your Christmas wish list, or you want to gift it to someone else so you can be the household hero, just head to crunchlabs.com or use the link in the video description. Now, as far as my plan to bounce back from my own failure, we did 4 things to really get serious and stack the dice in our favor for the final launch. First of all, we fixed the connection point with more of a sheath design that could handle the bending moment. And then at the right altitude, it would autonomously separate the 2 halves with a black powder charge. Second, we ran some vacuum and temperature tests on a raw egg. There's no air pressure and it's really, really cold in space. So if you don't do something to protect the egg for the 2 hours it takes the balloon to get up to space, it will freeze and crack the egg every time. So we tested some heaters in our egg chamber and proved that they keep the egg warm enough. Third, we built redundancy into our system. When NASA sends something to Mars, they can't go there to fix it, so it just has to work. And for that reason, a lot of critical systems have backups. Even the part of my own hardware and Curiosity that accepted a dirt sample from the arm into the belly of the rover had 2 doors that opened to the exact same place in case one of the doors ever stopped working. In our case, redundancy meant making a 2-foot wide custom beach ball that we would stuff with a second egg surrounded in packing materials with a 20-foot streamer on the back we would just drop like a rock. It would be dead simple. No parachutes to deploy, no autonomous timing sequences, and no fancy mechanisms. This would be our redundant, yet I would argue kind of boring, second chance opportunity to land a safe egg. And fourth and finally, we went to a local crane yard to test both our solutions at their respective terminal velocities, starting first with the beach ball.
Come on, baby! Oh.
She's alive!
And after that, we tested the final landing configuration of the rocket.
Oh yeah! Oh yeah! By the way, the actual rover parachute held perfectly. Mwah!
And so after all that, we made the 6-hour trek back to the desert for what I was really hoping would be the last time.
Hey guys!
After 4 failed attempts, we had learned so much, which left me feeling cautiously optimistic. And right out of the gate, we got 2 bits of really good news. The first relates to that super delicate zero pressure balloon we had to reuse from the last launch because there was no possible way to get a replacement. Just barely touching the balloon leaves it stressed and creates a weak point for it to tear, so I was obsessively checking the fish scale reading that would give us the verdict.
The force reading is 37.6 kilograms of buoyancy force pulling this up. Importantly, it's not changing. If it were changing and going down, that means we would have a leak, but it's holding steady at 37.6. That's a big deal.
And the second piece of good news is my buddy and warm-blooded good luck charm Al Chen had arrived. You might recognize Al as the other guy here with Adam, and he's the one who actually said this.
Touchdown confirmed. We're safe on Mars.
If we were successful, he'd be the one to make the official call. And so after all the requisite last-minute preparations and 3 long years,
Here we go, girl.
it was finally time for liftoff.
Ready? 3, 2, 1! You
And everything was looking good. The balloon ascent rate was just what we predicted, and that meant we for sure didn't have a leak, and things were finally breaking our way.
Is that how it's supposed to look? Yeah.
And it takes about 2 hours to get all the way up to space.
Whoa.
So once the balloon hit 30,000 feet, we decided to hop in the car so we could drive over to the predicted landing spot about 45 minutes away.
So far, it's all systems nominal. Balloons in the air, it's ascending at the right rate. We've passed some critical threshold points, and we're still in the game. 5th time is the charm, as they say.
And we eventually started outrunning the balloon in the car, so we pulled over for a bit as we reached an important altitude milestone of 100,000 feet.
I would say over 100.
Woo! Over 100.
That's 19 miles up and 2.5 times higher than a typical commercial plane flies. And because the balloon expands so large as it rises, we realized we could actually even spot it from the ground, which was awesome.
Yeah, no, I see it, yeah.
Dude, that's totally it.
What wasn't awesome was when moments later Joe, while looking through the binoculars, made this gut-wrenching observation.
It looked really big and then it looked really small.
You saw it small?
Yeah, it like seemed to be smaller.
But it's just weird that it would just completely disappear.
Which was followed by a devastating call from the balloon tracking team.
It dropped within the last 2 minutes.
Yeah.
That's 30,000 feet over the last however, so it's just popped.
But these don't pop, there's zero pressure.
And that's true, they don't pop. But unbeknownst to us, while we were looking at it from the ground, the rocket and beach ball had been spinning around and around relative to the balloon for about 10 minutes. This meant the cord that attaches to the string that self-destructs the balloon was getting wrapped around tighter and tighter until it was so tight, it pulled down on the balloon string that is designed to essentially unzip and destroy itself. And so before we even had the chance to release the rocket and beach ball from the balloon, it all started coming down in one big tangled heap at 150 miles per hour, which is way faster than the eggs could survive.
Well, let's start driving.
And as we drove over, all I could think about was how our fate would rest solely in the hands of the redundant systems we'd put in place.
We think it's probably about 2 miles up that way.
This was our Apollo 13 moment. If our payload could autonomously jettison itself from the tangled rocket balloon mess at 20,000 feet, then it would be able to deploy our lucky orange parachute and land the eggs safely on its airbags. And as we parked, we knew what was done was done. There was nothing left to do but go on a hunt to find the wreckage and reveal our fate.
I see something orange. That looks like a rover parachute. Okay. We've got a thing.
And seeing the payload all by itself was a huge deal, because it meant it had actually autonomously ejected itself from the mangled weather balloon mess at 20,000 feet. And later when we checked the footage, this is exactly what it confirmed. And while that was incredible news, I knew by this point not to get my hopes up.
I mean, so let's look through the window, a little bit of dirt. You see.
Pretty good, definitely touched down, but
Touchdown confirmed. Whether or not we're safe on Earth is TBD, right?
Let's check it out to be sure. Oh man. Touchdown confirmed. We're safe on Earth.
We're safe on Earth! That is a hot egg. It was in space and now it's on Earth and it's not broken. After that, we tracked down the beach ball, which as far as I was concerned, was just extra credit at this point. This is the backup, the simple solution, the true engineer solution here.
Oh my God. Look at that. Touchdown confirmed. Look at that. We're safe on Earth.
We are safe on Earth! 2 for 2, baby! 2 for 2! And as we walked away with 2 uncracked eggs in hand, I was reminded that in life, things rarely unfold how we think they will, but by learning from your failures, coupled with a bit of tenacity, us humans can accomplish a feat as incredible as the world's smartest Martian robot, or as ridiculous as the world's tallest egg drop. You know what would be cool? Because I hope you learned something by watching this video, but how much more would you have learned if you were out there in the desert with me, helping to troubleshoot and put the rocket together? Well, I got great news for you, because I got the next best thing, and it's called the Crunch Labs Build Box. It's a toy that gets delivered right to your doorstep every month, and then we build it together while I teach you all the juicy physics that make it work. You're basically unlocking your own personal Mark Rober video every month, where you learn a new engineering principle that will have you not just building like an engineer, but more importantly, thinking like an engineer. So you develop that resilience and those problem-solving skills. And by the way, don't go sleeping on just how cool the toys we'll be building together actually are. Like this insanely accurate rapid-fire disc launcher, or this linkage-powered drawing machine, or this Rube Goldberg-style catapult launcher that will leave you feeling like you just landed your own dang egg from space. And I should mention that Crunch Labs is a real place. It's where we design all these boxes, and it's got a tennis ball cannon, and the world's longest Hot Wheels track, and a foam pit, and a bunch of other cool inventions. And each month when you open your box that comes in the mail, you have a chance to find the platinum ticket. And if your box has it, that means you and your family get to come out and visit me and my team for a day, and we'll build some cool stuff together. So if you want to embark on this year-long journey with me and make a sad Christmas tree like this a happy Christmas tree, just go to crunchlabs.com or use the link in the video description where we're giving away 2 months free as a holiday special.